In an earlier video, I've talked about the idea of gravitational potential as opposed to gravitational potential energy. Now, gravitational potential energy I'll call that EP, as we've seen, is given by this formula, minus G mm over R. But gravitational potential is given by this formula. If I use the symbol phi, before it gets too confusing, let me remind ourselves that this is potential energy and this is potential. This is potential. The potential is defined by the potential energy divided by the mass, or the potential energy for a unit mass, for example, for 1 kilogram. And that formula, if you use this, then m and m cancel, and it's Gmm over R. Now, if we recall the meaning of that potential energy is the work done to bring a body from infinity to this place, to this point. Okay, that's the potential energy at this point. Then potential would refer to the same thing, except that it is the work done to bring a unit mass from infinity to here. So not just any mass, but a unit mass, which would be a kilogram in SI units. So let me write out this definition again for potential. Potential is it always has to refer to a particular position or point in space. So position adds a point is work done to bring a unit mass from infinity to the point. So the point here means a point in space, like down here. I call this at that point. Okay, so that's how gravitational potential is defined. It's defined for a unit mass. Now, can we have a similar meaning, a corresponding potential for electricity, for electric field? We can. So let me start with the potential energy as well, the electric potential energy. Now, this is given by the formula that we have seen in the past few videos. It's given by Q times Q. So this time I would drop the minus sign. It's understood that if any of these charges is negative, the negative value of the charge must be included in the symbol Q. So it's QQ divided by 4 pi epsilon naught epsilon naught R. So this is the formula for electric potential. What about electric, or this is the formula for electric potential energy. Okay. That's electric potential energy. So now I want to talk about electric potential. Now I want to emphasize the word electric, because unlike gravitational potential, and unlike potential energy or force, in which it's the same quantity, either force or energy, that we're talking about, the gravitational potential refers to there's a slight difference between gravitational potential and electric potential energy. There's a slight difference between gravitational potential and electric potential. Right? Whereas in the case of gravitational potential, it's the potential energy divided by mass, or for a unit mass. In the case of electric potential, it is not the it's not the potential energy for unit mass anymore. So what is it exactly? I'll use the symbol V, which is normally used for electric potential. Okay, it would be the electric potential energy divided not by the mass of that object, but by the charge divided by Q. So this is the formula. Alright, it's not for a unit mass, it's for a unit charge. So there's a basic difference between electric potential and gravitational potential. But the idea is the same. Right? The rest of the idea is the same, except that we talk about charge instead of mass. So we can make a formula for this using the electric potential energy formula. Just that is the U here. So just substitute that into here, and you find that the little q here and here cancel. So you're left with the big Q over 4 pi epsilon naught R. So there's still a lot of similarity, and in fact most of the meaning would be the same for an electric potential. So let me see how I would modify it. So if instead of gravitational potential, I'm talking about electric potential, I would add the word electric potential in its definition. Electric potential at a point is work done to bring unit, it won't be mass, it will be unit charge from infinity to the points.